Hello boys and girls, welcome to Mrs. Spandu's Math Movies. This is for my algebra class, Lesson 5-2, Relations and Functions. So our objectives in this lesson are to identify relations and functions and then evaluate functions. We do have several definitions. Some of them we should be familiar with because we have actually used already this year in class. Anyway, we're going to write them again because they're important. So here we go. A function is a relationship that assigns exactly one output value for each input value. Okay. Remember now, also the output values would be normally, if we're thinking about ordered pairs, and we will be doing a lot of graphing here, that would be your y value, where your input value is generally your x value. That's just a little FYI. We will be talking about that as we move through. Okay, a relation is simply a set of ordered pairs. Okay, and it is a set, so we use set notation. We would list them in the set brackets there, the set notation brackets. The domain of a relation is the values of the input. Again, this is a set, so we would use set notation. Generally, these would be considered our x values and our independent variable as well. So you might want to jot that. Generally, x values, independent variables. Okay, the range of a relation is the values of the output. Okay, again, these would be the set of y values or the dependent variables for a particular relation or function. Okay. Now, the vertical line test says that on the graph of a relation, if a vertical line passes through a graph more than once, the graph is not a function. So if you have a set of ordered pairs graph that are related to a function or to a relation, okay, then this is a test that you can use. Somebody sliding a straight edge, your pencil, the edge of a sheet of paper, so forth, across your paper. If something's graph, it's a quick, easy way to determine whether or not it's a function. As we go through one of our examples, we'll have something that we can look at, and I'll show you there. A function rule is simply an equation that describes a function. Function notation is writing a function rule using function notation, which would be f and then in parentheses the variable read as f of x to indicate outputs. Okay, now generally speaking that means f of x instead of y. So you trade off the two basically. Okay, so don't let that freak you out too much either. It just looks a little fancier when you look at it. They mean the same thing though, for all practical purposes. Okay, now using a mapping diagram. Determine whether each relation is a function. So here is how a diagram might be set up. You have your domain values, and you don't repeat any of them, okay? And then you have your range values. It says the domain value 2, which we see right here, corresponds to two range values, -1 and 4. Because of that, the relation is not a function. Okay, so that's what it means by the relation. A function assigns exactly one output value for each input value. This input value of 2 gave me two different answers, so that disqualifies it from being a function. Okay. All right. Here are some quick checks down here. You can go ahead and do your diagrams here to answer the question as to whether or not each relation is a function. Once again, pause now, come back to it later, whatever suits you. I am at the moment going to continue on to example number 2, using the vertical line test. It says, determine whether the relation, the set 0, -2, 1, -2, 3, 1, -2, 0, -1, 1, -1, -1, excuse me, 3, 2, and 2, -3 is a function. So what we want to do here is graph the relation. So I'm going to graph these 0, -2, okay, -1, excuse me, 1, -2, so over 1, down 2. -3, 1, so 3 left, 1, 2, 3, down 1. Up 1. My bad. This is not 1. Sorry. -2, 0, so -2, 0. It's right on the x-axis. -1, -1, so left 1, down 1. 3, 2, 1, 2, 3, 1, 2. And 2, -3, 1, 2, 1, 2, 3. Okay, so you have your relation values plotted, and the vertical line test works like this. As you slide across, okay, there's only 1 on that one, because remember I X'd out that one. 1. At any time there are 2 points on the same vertical line, then it fails the vertical line test and it is not a function. So far, nothing has been on the same vertical line at the same time, or has appeared on the same vertical line, and it doesn't. Okay, so no vertical line passes through more than 1 point. The relation is a function. Okay, so quick and easy visual. You can also use a pen or your pencil, because that's going to be able to isolate, so that you can see. And usually most of, a lot of times there'll be whole number coordinates when we're actually trying to graph, so that it's going to be easier to tell. The reality is it doesn't have to be whole numbers either, though. Okay. All right, making a table from a function rule. It says make a table for f of x equal to -5x plus 25. We're going to use the values -2, 0, 2, and 4 as domain values. So they already have this set up for you. My x values showing the function and the f of x, the output. Again, remember, these are like the y values, if you want to keep that in the back of your mind. Okay, so I'm just going to fill in, and I'm just going to fill these in right here and then go back and do the math. Okay, -5 times 2 is 10, plus 25 is 35. Negative 5 times 0 is 0, plus 25 gives me 25. Negative 5 times 2 is negative 10, plus 25 is 15. And negative 5, 4 is negative 20 plus 25, which would be 5. Okay? So the domain values are 35. If I wanted to write them in a set, they would be 35, 25, 15, and 5. Again, set notation. Number 4, find the range. Finding the range. Okay, I just realized I think I may have misspoke. These are the range values. This is the domain, this is the range. I think I just misspoke, so my apologies for that. The domain and the range. Next one, finding the range. Evaluate the function rule f of g, so instead of x, we have g, equals negative 2g plus 4 to find the range for the domain negative 1, 3, and 5. So basically what we're going to do is 3 quick evaluations for these given numbers. So f of negative 1 is equal to negative 2 times negative 1 plus 4. So the function at negative 1 is equal to 2 plus 4, or the function at negative 1 is equal to 6. The function at 3 is negative 2 times 3 plus 4. So negative 2 times 3 is 6, plus 4. So the function at 3 is negative 6. Why did I write negative 6 there? That should be negative 2. My apologies. Okay. In this case, we're going to substitute in 5 for g. So the function at 5, f of 5, is equal to negative 2 times 5 plus 4. So f of 5 equals negative 2 times 5 is negative 10 plus 4. So the function at 5 is equal to negative 6. So the range is 6, negative 2, negative 6 for the given domain. Okay. Now sometimes if you get confused if x is range or domain, I think of as ordered pairs being in alphabetical order, so the domain and then the range. That might be a little hint. And I do sometimes have to pause and catch myself because it is, if I'm not careful, I do get them confused. Okay, so please have your quick checks for this section done next time we meet. Any questions that you have, bring in. Look forward to